Viscosity. Viscosity is the physical property that characterizes the flow of resistance of simple fluids. Viscosity is a property of fluids by virtue of its offer resistance to the movement of one layer of fluid over an adjacent layer. The viscosity of fluid is a measure of its resistance to deformation at the given rate for liquids. It corresponds to the informal concept of thickness. For example, syrup has a higher viscosity than water. So, as you can see in the picture, viscosity is the measure of a fluid's resistance to flow. Water, lower viscosity, 1.0 centipoise, and honey, higher viscosity, 12,200.0 centipoise. Viscosity can conceptualize as a qualifying the internal friction force that arises between adjacent layer of fluid that are in relative motion. For instance, when a viscous fluid is forced through a tube, it flows more quickly near the tube's axis than near its wall. In such a case, experiments show that some stress, such as pressure different between the two ends of the tube, is needed to sustain the flow through the tube. This is because a force is required to overcome the friction between the layer of the fluid which are in relative motion. So for a tube with constant rate of flow, the strength of the compensating force is proportional to the fluid's viscosity. Next is Newton's law of viscosity. Newton's viscosity laws state that the shear stress between adjacent fluid layer is proportional to the velocity gradients between the two layers. The ratio of shear stress to shear rates is constant for a given temperature and pressure, and it is defined as the velocity or coefficients of viscosity. So this is the Newton's law of viscosity. A material property depending on the fluid and operating variables, T and P. Shear stress, force acting in the x direction applied over a surface oriented according to the y direction. Velocity gradients, shear rate, with velocity in the x direction varying along the y direction. Newtonian fluids. A fluid whose viscosity does not change with the rate of deformation or shear V and Y is called Newtonian's fluid. A fluid which obeys Newton's law of viscosity is termed as Newtonian's fluid. A Newtonian fluid is a fluid in which the viscous stresses arising from its flow at every point are linearly correlated to the local strain rate, the rate of change, and its deformation over time. That is equivalent to saying those forces are proportional to the rates of change of the fluid's velocity vector as one moves away from the point in question in various directions. More precisely, a fluid is Newtonian only if the tensor of describe the viscous stress and the strain rate are related by a constant viscosity tensor that does not depend on the stress state and velocity of the flow. If the fluid is also isotropic, that is, its mechanical properties are the same along any direction, the viscosity tensor reduced to two real coefficients describing the fluid's resistance to continuous shear deformation and continuous compression or expansion, respectively. Newtonian fluids have linear relationship between shear stress T and velocity gradients du and dy in the direction perpendicular to the flow direction. This equation is called the viscosity law of Newton. The velocity gradients du and dy is also often called the shear rate. As mentioned earlier, for equal pressure and temperature, the viscosity is constant. This means that Newtonian fluid do not have a memory for deformation in the past. And next is non-Newtonian fluid. A fluid whose viscosity change with the rate of deformation or shear strain V and Y is called non-Newtonian fluid. A fluid which does not obey Newton's law of viscosity is termed as non-Newtonian fluid. A Newtonian fluid is a fluid that does not follow Newton's law of viscosity. Constant viscosity independent of stress. In non-Newtonian fluids, viscosity can change when under force or either more liquid or more solid. Ketchup, for example, becomes runnier when shaken and it does a non-Newtonian fluid. Many salt solution and molten moliners are non-Newtonian fluids, as are many commonly found substances such as custard, toothpaste, starch suspension, cornstarch, paint, blood, melted butter, and shampoo. Most commonly, the viscosity, the gradual deformation by shear or tensile stresses of non-Newtonian fluid is dependent on shear rate or shear rate history. Some non-Newtonian fluid with shear-independent viscosity, however, still exhibit normal stress differences or other non-Newtonian behavior. In a Newtonian fluid, the relationship between the shear stress and the shear rate is linear, passing through a origin, the constant of proportionality being coefficient of viscosity. In non-Newtonian fluid, the relation between the shear stress and the shear rate is different. The fluid can even exhibit time-dependent viscosity. Therefore, a constant coefficient of viscosity cannot be defined. Fluids and solids fundamentals. A fluid cannot resist the deformation force it moves or flows under. The action of the force, its shapes will change continuously as long as the force is applied. We normally recognize three states of matter: solid, liquid, and gas. However, liquid and gas are both fluids. In contrast to solid, they lack the ability to resist deformation. Because a fluid cannot resist deformation force, it moves or flows under the action of the force. Its shape will change continuously as long as the force is applied. A solid can resist a deformation force while at rest. While a force may cause some displacement, the solid does not move indifferently. Some characteristics of fluids: pressure, force or unit area; temperature, kinetic energy of molecules; mass, the quantity or matter; molecular mass or mole; density, mass or unit volume; specific volume, 1 or P; dynamic viscosity, mass, length, and time. Dynamic viscosity presents the stickiness of the fluid. Important fluid properties. A fluid does care how fast it is deformed. It resists to motion depends on the rate of deformation. The other importance of fluid property are: a fluid does not care how much it is deformed. It is oblivious to its shape. Fluid does not care how fast it is deformed. Its resistance to motion depends on the rate of deformation. The property of fluid which indicates how much it resists to rate of deformation is the dynamic viscosity. Important fluid properties is: one element of a fluid moves, it tends to carry other element with it. That is, a fluid tends to stick to itself. The other important fluid properties are: if one element of fluid moves, it tends to carry another element with it. That is, a fluid tends to stick to itself. Dynamic viscosity represents the rate at which motion or momentum can be transferred through the flow. Fluid cannot have an abrupt discontinuity in velocity. There is always a transition region where the velocity changes continuously. Fluid do not slip with respect to solid. They tend to stick to objects such as the wall of enclosure. So the velocity of the fluid at a solid interface is the same as the velocity of the solid. Fluid and solid. When a constant shear force is applied, solid deforms or bends, can't resist a shear stress. Fluid continuously deform, cannot resist shear stress. Figure A is solid and figure B is fluid. Thank you.